Hi everybody, welcome to Properties of Matter, Chemistry 2020, the year of COVID changes everything. So we are going to start doing our lectures via videos of the PowerPoints. Not going to stand up in front of class and lecture about it because we're finding that many of you are just tuning this out and you're not getting the material. So instead what we're going to do is we're going to do these videos. It's just going to walk you through the video. Video will either be embedded in an Edpuzzle with questions or will be a standalone with a Google form set of questions at the end. Regardless of which way we present it, and you know what, there may be a third or a fourth, you will be required to complete the Edpuzzle or the Google form or whatever assignment has been made with it within the class day. Most of the time it should be within a class period, but if I don't do my time well, it might be by the end of the day. The assignment is due when it is due. Late assignments will not be given a passing grade. All right, so let's get started with this. Properties of matter. We all understand that matter is described and it has properties, right? We can talk about it. We know it has mass and it takes up space. But beyond that, what are we talking about? Learning objectives for today: to recognize the differences between physical properties and chemical properties. Then also to recognize the difference between intensive and extensive properties. Now in Google Classroom today, you were given a checklist and it has very specific, detailed examples of learning objectives and success criterion that you will need to use as you prepare for the test. But let's go ahead and talk about these two major learning objectives. All right. We understand that when we're describing things, we can tell the difference between a pen and a pencil. You know, they're both lines. They're made up of atoms. So how come they're really different? How are they different? We know, atoms are all made up of protons, neutrons, and electrons. We know some have more protons, some have less protons, but they're not different. One proton is no different than another. So why does matter have different properties? The difference is how the atoms are combined to make the line or the object. And we use properties of matter to describe these differences. All right, so let's get into this. We know that physical properties are any characteristic that can be determined without changing the substance chemical identity. All right, so you see before we talk, I'm going to go ahead and give you the definition of chemical properties, and then what we're going to do is I'm going to ask you to pause the video and talk to the person next to you or near you, and together come up with 5 or more physical properties and 3 or more chemical properties we use to describe matter. All right, so again, there's your definition of physical properties. When we look at chemical properties, we say any characteristic that describes how a substance reacts with other substances. It requires that a substance molecular structure changes. So physical properties are properties that stand alone. What are we looking at? Chemical properties, what does something do? All right, so go ahead and pause the video and just for a few minutes, talk to somebody and come up with a couple of lists. Hey, welcome back. So let's just talk about some physical properties. Again, I walked around during class and listened to you. I listened to both your physical properties conversation and chemical properties conversation. Those of you who were at home, I did not say this to you, but I'll go ahead and tell you, I hope you were talking to somebody and getting something, at least wrote some stuff down. All right, so let's talk about some physical properties. All right, physical properties would be, for example, the melting and freezing point of, say, water. That doesn't change. All right, if it melts, it's still water. If it freezes, it's still water. If it boils, it's still water. But you can talk about the temperature at which it does that, and that's a physical property. You can talk about the texture and the hardness of something. Does it dissolve in water or not? Is it a solid? Is it a liquid? Is it a gas? Those are physical properties. By talking about something as a solid, we're not saying it's changing. We're just talking about what does it look like right now. The color, the density, which is mass over volume. The volume, how much size, the size of it. Does it take up a lot of space? The boiling point, the shape, and the mass. For example, I'm going to talk about my computer mouse right now. And I'm going to tell you that it's yellow. I'm going to tell you that its shape is not like a regular computer mouse, but instead it's the shape of something that if you were to see it on the road, you would probably, hit the person next time and say, punch bug. Right? So I just described my mouse. I told you its shape and its color. Can you tell me what it was? That's a yellow Volkswagen. Right? My mouse is the shape of a yellow Volkswagen Bug. Why? Because it was the first car I ever owned, and somebody found one and they bought it for me, and I love my computer mouse. Okay? Oh, by the way, it's a solid. All right? Okay, chemical properties. Any characteristic that describes how a substance reacts. So, let's just talk about this. We know that wood does a few things. We know it burns. That means it's flammable. We know it's flammable. We know that certain metals on the periodic table react with water. We know that iron, the iron in the air when water is present reacts with the oxygen to create this thing called rust. I can promise you a piece of wood doesn't rust. Some things bond with oxygen, some things don't. Some things decompose when heated. All right, so these are things that are chemical properties, and it requires that a chemical or an object do something else and change its structure or who it is by doing this property or by using this property. All right. Okay, so the other part of this, and that was just a real quick run view, we'll go through more later, are these two things called extensive and intensive properties. These are tough. They are so tough that we actually have another video over this tomorrow, but I need you to get the basic definitions today. Extensive properties. Any characteristic of matter that depends on the amount of matter. Okay? That would be measurement things. We can measure how much mass something has, how long it is, what its volume it is. These are additive. If I add more of something, this property changes. And you guys are going to do a quick little lab on Wednesday or Thursday block day. And you're going to see how extensive properties versus intensive using one particular material. I'm going to ask you to describe it, and then we're going to talk about how when we add more of it, certain things change, but other things don't change. All right? Intensive properties. Any characteristic of matter that it is independent of the amount of substance present is not additive. The color. The melting point. I hate to tell you, water melts at 0 degrees Celsius, whether it's a tiny ice cube or whether it's in a gallon jug. It does not matter how much it is, it keeps the same melting point. Materials themselves, like substances, iron has a certain density. You can find it on the periodic table. Now, a boat, on the other hand, has a different density, but it's not, we're talking about two different materials. Okay, so these are two things that you're going to struggle with. Extensive means that you can do something to the outside and it changes. Intensive talks about a property that comes from within. All right, try that. Okay, chemical properties are intensive. All right, so there's a couple questions here. I'm going to let you kind of look at this. Properties of matter. Are the properties determined without changing the identity? If it's yes, it's physical. If it's no, it's chemical. All right, then you have the definition. How does a substance react in the presence of air? An acid, water. Bases, other chemicals. What happens if it's heated? These are just some questions and things to consider. Physical properties. Your intensive and extensive properties are physical properties. All, chemicals are all intensive. Extensive properties depend on the amount. Intensive do not depend on the amount. All right, so there's some other ways to classify matter. We can talk about these. This will actually be next week. We'll spend a lot more time with it next week. We're going to spend a little bit more time with it tomorrow. I think it's tomorrow. No, it's next week, sorry. Yes, that's right. And we're talking about solids, liquids, and gases. This is not a composition way to classify matter. It's using a property. What we did last week was composition. This week we're talking about properties. And we understand there's a lot of difference in the solids, liquids, and gases. We'll talk more about that later. Please remember there is a fourth state of matter, that is plasma. Another property that we can use to classify matter other than composition, is it a metal or is it a nonmetal? Well, those are physical properties that we use to describe things, but we can classify metal that way, or materials that way. Metals are shiny, they conduct electricity and heat. They are malleable and ductile. Malleable means that they can be bent. Ductile means they can be pulled into a long wire. Most of them are solid at room temperature. Your nonmetals, on the other hand, don't conduct electricity or heat. Instead of being able to bend and move, they're brittle. And at room temperature, many of them are gases. But these are all physical properties that help us describe a nonmetal and a metal that we can then use to classify matter. All right. When we're looking at another property of matter that can be used to classify it, it's whether or not it's magnetic. There are three types of magnetism. Diamagnetism refers to materials that cannot be affected by a magnetic field, which means, guess what? They're not magnetic. Paramagnetism refers to materials which, if we put something magnetic next to it, it becomes magnetic. But the magnetism disappears when that other thing is moved, when another magnet is there. Okay? And ferromagnetism refers to the three materials, iron, cobalt, and nickel, which are all three elements, that retain their magnetic properties even when we've removed the magnetic field. They're always magnetic. All right, so let's talk about the take-home points. All properties of matter are either physical or chemical. Physical properties are either intensive or extensive. All chemical properties are intensive. I don't have that in here, but you need to know that. Extensive properties such as mass and volume depend on the amount. Intensive properties, density and color, do not depend on the amount. Physical properties can be measured, determined, observed without changing a substance chemical identity. And chemical properties can only be measured or be measured only by changing a substance chemical identity. So it's a process. Chemical properties are more or less processes. We call them words, but it burns. Burning is a process that changes who it is. That's a chemical property. Some things can burn, other things cannot. All right, so that's it, guys.